Okay guys, gonna have a look here at Surface Geometry Sheet 1 from GCG Solutions, those worksheets. So, first question here. Try and read the question carefully now. So, A and B both have angles of 35 degrees to the horizontal plane. So, the easiest way to do that is just go around to the side, look in, so put an XY line. You're over here looking in at it. So just project them over. Get your protractor. Go off at an angle of 35 degrees to the horizontal plane. So that's our angle. You don't need to do the full thing really, because all we wanted is the height, but sure, I might as well anyway. So 35 degrees from both sides there. So the height here is 17. Okay. So just step up that height there. And project up the sides of the tent. So basically that height here gives us that height here. That's what we were looking for in that side view there. So that was grand. On to the next one here then. So question 2 here. Question 2. So A and B, complete the plan given that surface A makes an angle of 60 degrees with the horizontal plane. So that's an angle of 60 degrees here. That angle there is 60 degrees. Now look, one way of doing this is just you could make a cone. You could make a 60 degree cone at this corner here. If I call that 1 and 2, that's 1 and 2. If you said that was the axis of a 60 degree cone, so I might even put it in blue. So that's a 60 degree cone, or half a cone anyway. Or a quarter of a cone. It doesn't matter really what fraction of the cone it is. But the base of that cone, if you were looking down from above, the base of that cone, I'll just draw half of the cone I suppose, but the base of that cone, that's the base radius of it, so that distance there is what we were looking for. So here's my top view. And that there is A and B. Now, I could also have done this using an auxiliary. If I set up an XY line there, projected this out, projected that out, take the height of the top of that surface here and go off at an angle of 60 degrees to the ground. which would be like this. Like that's a 60 degrees there, and like that would have given me the exact same distance here. It's like what is the distance and plan of that. So that's two ways of doing that one. I'll move on there to question. So that was 1 and 3 done. So question 2. So A and B have slopes of 45 and 30. So A is 45 and B is 30 degrees to the ground. So that's 45 degrees, but this one back here that we can't see is 30 degrees. So again, like the first one there, go over here. You're going to go over here and basically look in there from that side, project these out. That's on the ground, this is on the ground. Get your protractor. So this angle is 45. So that's 45. This one is 30. So now we have the height of it for the front view. So the height of that for the front view is 19. So the height of that is there, and the left and right hand sides when I project them up are here. Now it says there that C and D then are 50 degree angles. So in the front view we're going to be going off at 50 degrees. Degrees here. $50 there. So that is the front view. That height is that's where we got our height for there. And then the top view then, if that's the ridge of the roof there, bring these down. So there's the ridge of the roof. Because it's not symmetrical, the ridge is not going back to center. Okay, so 30, 45 and 50 degrees to the ground, 50 degrees to the ground. So those are the angles there for all them. So yeah, so that is question 2 done, and I had 3 done. So incredibly, that leaves question 4. So surface B has an angle of 35 degrees to the ground. Okay, now there's kind of 2 ways of doing this. And like generally with these, what you're trying to do is find heights. So like that corner there, that's on the ground. This point here is on the ground. That point there is on the ground. and then these ones are all up in the air. But we need to find the height basically of them. So like you could do it out separate completely. This here is a plan distance. That distance there, look. I could just take that plan distance, looking down on top of that, that is 41. Here is like maybe a slightly different way of doing it now, but hopefully we'll understand it. 45, 14, okay. So there's 41, which is coming from here. That's my plan distance. That's going up vertically, and the angle is 35 degrees. So if I just step up an angle of 35 degrees across a plan distance of 41, that is giving me a height here of, say, about 29. So I could just step up my 29 here and do that. Now, other ways of doing it is I could, because the ends of that are 90 degrees, I could just put on a XY line. Look out here. So that's on the ground. This one is up in the air. No, this is basically doing the same thing again down here. That's your 35 degrees. So that there is the height, and by right that should be the same height, so that should be 29, which it is. So I'm going to step that height up there, and the top of this is horizontal. No, the top of this doesn't have to be horizontal, but the top of that is horizontal anyway. Because that and that are parallel, and that are parallel. So because they're parallel, it means if that's horizontal, this is horizontal. So it wouldn't absolutely have to be horizontal like that, but it just is in this particular question. So that's on the ground going up to here. That's up there. So that's surface A here. This is surface B. That's the side down here, and our height there of 29. So that there is sheet 1 anyway.